So this first talk is on primary production in the North Sea and its trophic effects within the food web. And this is a study we've been doing in the lab with a number of scientists. Elisa Kaputso is the real phytoplankton expert, and we're involved in trying to use this information to generate useful indicators, particularly for the OSPAR intermediate assessment in 2017. So we're going right back to the base of the food web now to understand primary production. And of course there are many, many species, diatoms and dinoflagellate groups that compose the base of the food web. Then life forms which are important prey for zooplankton and higher predators. But phytoplankton biomass or chlorophyll that we often measure is not the same as primary production. So if phytoplankton biomass, chlorophyll is what we have in the bank, that's the result of what we're putting in addition to what's coming out of the system. And it's this production that we're particularly interested in here, which is supporting the mass at higher trophic levels. So primary production is what's going into the bank, it's our deposits, the biomass is balance, and then we have other things, removals and grazing and other mortalities, reducing that biomass. So we're going to focus on primary production. And when we wanted to look in the literature, see what data were available, is actually there's very scarce data in the literature. It's very difficult to find any mapped information on primary production. So we had to go back to 1993 to this map from Joint and Pomeroy showing the distribution of primary production within the southern North Sea. But we know since then there's been large changes in the environment of the North Sea, and the water has changed in clarity. Some work by Elisa has shown this. So in the early 20th century, the North Sea was quite clear. We had a lot of phytoplankton, a lot of production, and we had quite a strong benthic macrofauna community filtering the water. So these were very good conditions. It's since changed, particularly in the southern North Sea, where we have increased coastal erosion, more sediment in the water column, so it's darker water, it's less good conditions for the growth of phytoplankton, and we have trawling, removing a lot of the filter feeders, cleaning the system, and we have increased waves through increased windiness, possibly as a result of climate change. So the questions around this that we've asked are simply, has the decrease in water clarity led to a decrease in phytoplankton primary production, and what impact might that have on the food web? So have the changes in primary production been reflected in the dynamics of the zooplankton and in the production of fish, so the recruitment information? So to estimate primary production, this is the only equation I'll show. We want to know how much chlorophyll is in the water column, but we also want to know how much light is incident on the water column. The more light there is, the more energy going into the system. But also it's how that light makes it into the water column, how quickly it attenuates when it gets darker. It's important. So we did some experiments within the lab to identify some of the parameters for this equation. And so we can now use it with some cost-effective sampling at sea. But of course, it's not more light gives you more and more production. Eventually, you reach a limit at which you get maximum production, and potentially even a little bit less with too much light. So what we have in the lab and through ICs, through the data center there, is we had gathered lots of data on chlorophyll biomass for the North Sea, collected on our vessel with fluorescence sampling. And we have information from light attenuation using Secchi-disc measurements. We've combined that with surface irradiance from NOAA and the additional experiments I've mentioned. And this is the data we collated over the last few decades worth of sampling. So the chlorophyll fluorescence you can see there on the middle plot. And there's a bias towards the southern North Sea. But as the plot of chlorophyll satellite imagery there shows us, that's really where a lot of production is. And it's also where we have the more turbid and darker waters. So we're taking that data and trying to use it spatially through this ecohydrodynamic zone approach that my colleagues in the lab, Van Leeuwen et al. Published last year, using the ERSIM modelling to look at physical stratification properties of the North Sea. And I identified these 5 ecohydrodynamic zones. And when we used our data and the equation I showed earlier, we found that yes, as expected in the mixed, more turbid waters of the southwest North Sea, we have lower primary production, and where the water has the influence from the fresh water outputs from the rivers, we have much higher production. And then we use the areas of those ecohydrodynamic zones to scale up the estimates of primary production at all the points to give us the gross annual production for the entire North Sea, those different zones. combined. And we see that we have lower primary production in the North Sea in the period after 2003 relative to the period before, and this sort of zigzag pattern. But overall, there's a decline with this sort of peak in 1995. So the question is do we see that sort of pattern in any other data for the higher trophic levels? So from the sort of Alistair Hardy Foundation for Ocean Science down in Plymouth, we have lots of data from zooplankton from the CPR survey, which we group into small and large copepod individuals, and it's really dominated by the small zooplankton. And we have the fish information from ices. And if we plot those out here for the North Sea as a whole, we can see that we do have general declining trends in the zooplankton, in addition to the recruitment of the main species there in the North Sea, cod, haddock, whiting, say, plaice, cod, haddock, whiting, say, and the pelagic species of herring and sprat, etc. But we don't get the same decline in biomass of fish species, because yes, recruitment's gone down, but we've also really reduced our fishing mortality, so the pressure has decreased. And these two things kind of cancel out to give us these fluctuations over time in the biomass of fish species overall. But it's very interesting when you look at the primary production data alongside the fish biomass, and you see actually very similar patterns. And the question that this throws up is, yes, we've been reducing our pressure because we didn't want to reduce the reproductive success of the fish stocks, but are we really actually managing something that's more fundamental and a change in the productivity of the system as a whole? So 2 papers have been produced supporting this work, and we're still working on these links between the primary production and upwards through the food chain. And this work is now supporting a pilot assessment within the OSPAR Intermediate Assessment in 2017, so we're having some impact also. Thank you very much.